Myself, Venkata Sruthi Muppa, and my teammates are Sushma Mandati and Sri Sai Singala. Today, I am here to explain our final project, wine quality prediction using machine learning algorithms. First, let's discuss about machine learning and its process. Then we will go into our project. Traditional programming involves writing explicit code to solve a problem, while machine learning involves creating a model that can learn from data and improve its performance over time. Here are some of the steps in machine learning processor. First step is it identifies relevant data sets and prepare them for analysis. And the second step is to choose the type of machine learning algorithm to use. And the third step is it builds an analytical model based on the chosen algorithm. And the fourth step is it trains the model on test data sets, revising it as needed. And the final step is it runs the model to generate the scores and other findings. And here comes our project wine quality prediction. Here we will predict the quality of wine on the basis of given features. We use wine quality dataset available on internet for free. Here we took the dataset from Cargill. This dataset has the fundamental features which are responsible for affecting the quality of the wine. By the use of several machine learning models, we will predict the quality of wine. The main motive of our project is to test the wine is of high quality and meet the expectations of consumer using different machine learning algorithms. And here we split the data into training data and testing data. The reason for splitting the data into training data and testing data is during the training phase, the machine learning algorithm is presented with a data set that includes input features and corresponding output labels. Testing after the model has been trained, it is tested on a separate set of data that it has not seen before. It is used to evaluate the performance of model. The main reason for separating data set is to ensure that the model does not overfit to the training data, which can result in poor performance of the model. First, there are five phases in machine learning process, and the first phase is to get the data. In this step, we need to give CSV file as an input, and the second step is we need to clear the data. Uh, that means we need to remove the duplicate values or null values that are present in the CSV file. And the third step and fourth step is as we training and testing the data. And the final step is to improve the model by using different machine learning algorithms. Here the input comes from the training model and the testing data. We use some libraries for implementing our code, and those are pandas, numpy, seaborn or matplotlib and sklearn. We need to read the dataset by using this function pd.read underscore csv. Describe function is used to understand the data by providing the statistical information of the data. That means count, mean, max, min, max values. We need to find the null values and we need to perform exploratory data analysis on the data set by using this function. This is the statistical distribution of different attributes of the data set. Those are fixed acidity, volatile acidity, citric acid, residual sugar, chloride, free sulfur dioxide, total sulfur dioxide density, pH, sulfates, alcohol and quality. We need to test all these functions in the data implementation. This is a bar graph of exploratory data analysis. It can be used to analyze and visualize various aspects of the wine dataset. We'll continue this topic about machine learning algorithms.
Hi, this is Sushma. We used four machine learning algorithms for doing this project: logistic regression, random forest classifier, decision tree classifier, and k nearest neighbors. Coming to the logistic regression. Logistic regression is a supervised learning algorithm used to predict a dependent categorical target variable. Here is a code for logistic regression, and the accuracy for this model is 88.75%. Here is a second model, which is decision tree. It is the most powerful and popular tool for classification and prediction. A decision tree is a flowchart like tree structure where each internal node denotes a test on an attribute, each branch represents an outcome of the test, and each leaf node, terminal node, holds a class label. Here is a code for decision tree, and the accuracy for this model is 86.67%. And here is our third model, which is random forest classifier. It is a classifier that contains a number of decision trees on various subsets of the given dataset and takes the average to improve the predictive accuracy of that dataset. Instead of relying on one decision tree, the random forest takes the prediction from each tree and based on the majority odds of predictions, and it predicts the final output. Here is a code for the random forest classifier, and the accuracy of this model is 89.38%. And the fourth model is K nearest neighbors. K nearest neighbor algorithm, often abbreviated as KNN, and it is an approach to data classification that estimates how likely a data point is to be a member of one group or the other depending on what group the data points nearest to it. Here is a code for the K nearest neighbors, and the accuracy of this model is 87.5%. My teammate Srisai will explain the implementation.
In this project, we are going to predict the wine quality using different machine learning algorithms. And we have imported all the required libraries like NumPy, Pandas, CPON, Matplotlib, sklearn, the logistic regression classifiers, decision tree classifier, random forest classifiers, k-neighbor classifiers. And we have imported the data from Kaggle.com. And we can see that our dataset contains of 1599 rows and 12 columns. And we have used the info method to show the more details about the data set like columns and data type of the columns. And we have checked the null values explicitly by using the null method. And we can here see that there are no null values in our data set. And describe method is to show the statistical data of the each column in the data set. And we can here here we can see that the mean standard deviation and minimum maximum of columns. And the count method gives the count of all values in the target column. And here we can see that in our target column, we have the values like 5, 6, 7, 4, 8, 3. And we have plotted the bar graph to show the count values in the target column. And we can see that quality 5 has more values in the target column. And here we can see that statistical distribution of each column in our data set. And we have plotted heat map to show the correlation between the columns. From this heat map, we can see that the column alcohol has highest correlation with the quality, our target column. And we can also see that column elasticity has the least correlation with the target column quality. And here also we have plotted the bar plot to show that quality of the wine increases with the alcohol percentage. And here we consider the quality greater than or equal to 7 as good wines and less than the 7 are bad wines. Now let's binary the data into 0 and 1. As quality greater than or equal to 7 assigned to 1 and the less than 7 assigned to 0. And we can see here the count of after binarizing data we can see the count here. And we have divided the data into x and y. In x we have dropped the column quality. And here we can see the shape of our training and test data. At first, we use the logistic regression. By using logistic regression, we obtained accuracy of 88.775%. And here we can see the classification report below. And next, we use the decision tree, and we have imported the libraries from sklearn, and we obtained accuracy of 86.67%. And we can see here the classification report of decision tree below. And we use the random forest. In random forest, we obtained accuracy of 89.38%. And here you can see the classification report of the random forest below. And next, we can see the k nearest neighbors. In k nearest neighbor, we obtained accuracy it's around 87.5%. And here we can see the classification report of the k nearest neighbor. By comparing all these methods, we can conclude that in random forest we are getting the more accuracy to predict the wine quality, and we obtained accuracy of 89.38%. So we conclude that random forest is the best suitable method to predict the wine quality. Thank you.
Of supervised learning, predictive analysis based on the problems of regression and classification, spam detection, pattern detection, natural language processing, sentiment analysis, image classification, and the sequence processing. Here are some of the advantages: clear understanding, layman learning process, expected output, well defined classes, storage efficient, efficient in classification problems, and the accurate prediction. Here are some of the disadvantages: difficult to handle complex tasks, hard to predict unknown information, classification and clustering is difficult, accuracy is dependent on data set, and the frequent supervision is required. Coming to the conclusion, random forest finally predicted with a good accuracy to our wine prediction model. As well, logistic regression model also resulted approximately the same accuracy value as a random forest. Thank you.